State the open intervals over which the function is A, increasing, B, decreasing, and C, constant. So here is our graph that we need to look at to see whether it is increasing, decreasing, or constant. Now for the first part, it says in part A, we want to select the correct choice to determine whether the function is increasing. Okay, so we need to determine where the function is increasing. So when you look at this graph, you always look at it from left to right. So when you start at this left point, it starts at this arrow, and you can see it's going down from left to right. Therefore, you can see where it's decreasing. And then from left to right, you can see where it's increasing. So from this point, you can see it's increasing up to that point. And then over here, it levels off, which means that it's constant. So we'll figure out how do we need to answer this question. Now, recall here that, and now definition-wise, it says if a function f is defined over an open interval I, open means that you use parentheses, you cannot use brackets, then f increases on the interval I if whenever the x-coordinate 1 is less than the x-coordinate 2. And then the output f of x1 is less than f of x2. So we're first going to go and identify where is it increasing. So I'm going to use a different color for increasing here. Okay, so it's increasing from this point here all the way up to there. That's where it's increasing. Okay. All right, so we're going to go ahead and see where it's increasing. So where it's increasing is from this point. So you can see the point is -1, -5, and it's increasing from -1 to -5 to 4 and then 6. Okay, so I want you to read this where it says, okay, where it's increasing, we have to look at this definition. Okay, what does x1 represent? Well, this is x1, okay, and this is x2. Okay, so is x1 less than x2? It checks. Okay, now let's find out f of x1. Well, this is the output f of x1, and this represents f of x2. So is f of x1, which is -5, less than f of x2? Well, that checks as well. Therefore, whenever that happens, we know that it's going to be increasing. It's rising from left to right. Okay, now the way we need to answer this question is on what interval is it increasing? Meaning that at what values, okay, is it increasing? And so it's increasing in the x values. And what are those x values? It's going from -1 to +4. So the answer is that it's increasing from -1 to 4. So let's go ahead and put our answer in there. So the function is increasing, and it's increasing from parentheses -1 to 4 parentheses. Make sure to put that negative symbol in there. Let's check our answer, and there is our result. Okay, now what we want to do is we want to now find out where is the function decreasing. So let's take a look at the graph here. All right, so where is it decreasing? We already talked about that. You can see that it's decreasing from left to right, from here to there, right? So on the open interval, you can see where it is decreasing. Now this arrow means that it's continuing, okay? So if we're looking at the decreasing function, okay, it's decreasing. So this is technically decreasing, but the arrow tells us that it's going towards the left, meaning that it's coming from -infinity, okay? And so now let's take a look at this ordered pair here, okay? So we know that it's going to be decreasing for the following. It's decreasing okay, and look at the points that they have. So there's an ordered pair that represents -7 and then 0, and it's going towards -1 and then -5. Okay, so let's take a look at this one. So x1, so we're looking at this scenario here. This is x1, and this is x2. Okay, so is x1 less than x2? Yes, -7 is less than -1. That checks. Okay, now we need to look at the outputs. Okay, so the output of x1, this is f of x1, and this is f of x2. Now, in order for this to work, f of x1 has to be greater than f of x2, meaning the output. Well, is 0 greater than -5? It is. Okay, now we need to write the open interval of where it's decreasing, which means that this negative infinity is important to make note. So we're going from -infinity, because that's how far it goes left on the x-axis. And then what is the point here? So it's going from -infinity because of the arrow. And then the x here is -1. So it's going to go from -infinity to -1, and there is the decreasing function. So we can see it's decreasing from parentheses -infinity, comma, -1 with the parenthesis, and there is our answer. Okay, now we want to figure out where is it constant. So let's take a look at that. Okay, now let's take a look here. So if, in this case here, if let me go ahead and make this a little bit easier for you to see here. All right, so we can see that if a function f is defined over an open interval I, then f is constant on the interval I if for every x1 and x2, f of x1 is equal to f of x2. And look for intervals over which the value of the function does not change. So we can see that it's constant from here to there. Okay, and let's take a look at those 2 points that they have. Now remember, this is an arrow that's continuing towards positive infinity over here. But let's take a look at this. So this represents a constant. Okay, and so we have the 2 ordered pairs. We have 4, 6, 2. The other ordered pair, 7, 6. Okay, so here we have x1, and then here we have x2. Okay, so we have 2 x1 and x2. But then it's saying that all the outputs must be equal to each other. Well, does f of x1 equal f of x2? Well, that does work. Therefore, it's constant. But now we need to write where it's constant according to the particular graph. Well, we're starting at the x value of 4, and it's going all the way towards positive infinity because this is an arrow that's telling us that. So it's constant on this interval. And let's go ahead and put that answer in here. So we have our answer here. So parentheses, 4, comma, positive infinity with a parenthesis, and then let's check our answer. Okay. Okay, now let's just verify the information on our graph. Okay, so the information on our graph says the following. Where was it decreasing on the x-axis? Well, it was decreasing from -infinity all the way to what point? Well, it was decreasing from -infinity to -1. So this is where it was decreasing. Okay, and then it was increasing from where on the x-axis? Well, it was increasing from -1 to 4. This is where it's increasing on the graph. And then where was it constant? Well, you can see that it was constant from 4 all the way to positive infinity. and this is where it was a constant. So you can see here how the x-axis is what's determining these intervals. But again, we need to look at the function to determine where it's increasing, decreasing, and constant.